Hi guys, this is David Villar and welcome to this next video on toxicants that affect the kidneys. On this one we will discuss ochratoxins and zinc toxicosis. Now ochratoxins comprise a series of at least 7 related metabolites of Aspergillus and Penicillium molds, of which the most toxic and common one is ochratoxin A. This is a contaminant of feed grains and cereals, and it's one of the key mycotoxins that should be included in any panel, as it has caused numerous cases of poisonings, particularly in pigs. As I say, swine are very sensitive, and experimentally doses between 1 and 3 milligrams per kilogram will kill them in a matter of 5 to 6 days. This would be very rare to happen, and the most common scenario is the ingestion of lower doses and for several months before they become sick. For example, a diet containing 1 part per million for 3 months will eventually lead to problems of polyuria, polydipsia, reduced growth rates, lower feed conversion, and impaired renal function. Now, cattle are very resistant because much of the toxin is broken down in the rumen, but obviously non-ruminant calves are sensitive. Doses starting at 0.1 milligram per kilogram per day for 3 months in calves of 30 days of age displayed signs of polyuria, polydipsia, CNS depression, decreased weight gains, isostenuria, and dehydration. On the table on the slide, we have the LD50s in several animal species, which show the very high toxicity of ochratoxin. However, this is all experimental, and you will probably never come across acute cases. As I say, most of the time the intoxication happens with continuous lower doses for a long time. This is what I wanted to get across. Chronic exposures will cause a nephropathy, and the first thing that the farmer will notice is reduced weight gains in pigs and poor feed efficiency. With high doses for several days, there will be damage in organs like the kidneys, the liver. And when the animal dies, there will be an enteritis, lymphoid depletion, liver necrosis, and obviously kidney necrosis. Now, another species which is also quite sensitive are chickens. I found on a study that fed broilers started 1 day of life for 6 weeks, and they found no effects at 100 parts per billion. When they gave a dose of 150 parts per billion, there was lower weight gains and feed efficiency. And when they sacrificed the animals, the internal organs had increased their relative weight compared to their body weights. At 200 parts per billion, there was the same effects as 150 parts per billion, and they had also more changes in the liver and kidney functions, and there were obviously more severe histological lesions. In hens, the same thing happens as broilers, but we have to add reduced egg production, depressed hatchability, poor progeny performance, and embryo mortality. Now, the next toxicant is zinc that has been reported in pets, horses, birds that usually ingest metal pieces like hardware, nails, nuts, bolts, or other galvanized metals. As you know, zinc is used to coat metals to prevent rusting. In dogs, a common source of ingestion is pennies that were minted after 1982. Those pennies contain 97.5% of zinc, which is about 2,400 milligrams of elemental zinc. In birds, galvanized metal cages is the typical source of zinc poisoning, particularly in parrots with the habit of chewing on the aviary wire mesh or the galvanized powder coated cage. You need to make sure that if you bring any toys into the aviary, they are probably not metal and definitely have to be free of zinc. In production animals, the source of the contaminated in production animals, the source can be either contaminated pastures, as we will see in a minute, but most of the time it's an excess supplementation of zinc in the diet. We also discuss zinc toxicosis in cattle, and in this case, now remember that zinc is an essential element that is a cofactor in at least 200 enzymes that are involved in multiple key functions in the body. On this table we see the requirement for different microminerals according to NRC, and as we can see, they all need to be provided in minute quantities of just a few milligrams per kilogram of the dry matter diet. And for zinc, those requirements are just 30 parts per million, or milligrams per kilogram of the dry matter diet. Now, the exact dose that can poison animals is not totally defined, but as if we look at this table with different studies, they start around 700 parts per million in the diet. And it is, as I say, it's hard to put a single value because the toxicity of zinc is going to depend on the type of salt given, for how long it's being consumed. And there are also, we should probably talk about some interactions that can also interfere with zinc metabolism. Now, I took a look at one of those papers. They cited as you see, is quite old, but they look at the effect of high levels of dietary zinc on gains, feed consumption, and feed efficiency in beef cattle. If we look at the table, the levels of supplementation were started at 0.1, 0.5, 0.9, 1.3, 1.3, 1.7, and 2.1 grams per kilogram of diet. And they recorded the gains and the feed consumption for 2 weeks during a 12-week period. As we see in the table, the first indication of toxicity was a reduction of feed consumption that took place early in the experiment. However, they say that the reduced consumption was only temporary and the appetite resumed later. So what they show here is that the weight gains were significantly depressed in a linear fashion with the increased zinc intake. The effect on gains was much greater than the depression of feed consumption, and this was reflected by a very large increase in feed required per unit of gain. In other words, the feed to gain ratio went from 10 all the way up to 124, which is more than 10 times. So the animal basically needs to consume a lot more feed to gain any weight. Now, as we can see on this figure, the dietary levels of 0.1 and 0.5 grams per kilogram had no effect on average daily gains in either steers or heifers, and they actually increased feed efficiency. Now, when they gave levels starting at 0.9 grams per kilogram, as you can see on the figure, there were reduced gains and feed efficiencies, so we could say that those are definitely toxic levels. Now, how much of a good thing is too much? This is a field case of chronic zinc poisoning in calves that were fed zinc-contaminated roughage. This case took place in the Netherlands, and the first thing they noted is that the calves of about 1 year of age had problems of pica, severe diarrhea, submandibular edema, pale mucous membranes, emaciation, and anorexia. They were being fed with grass and corn silage that was harvested in the vicinity of a factory that galvanized steel tubes. And they mentioned that the dust from the factory was regularly seen on the pastures. So they suspected zinc as the culprit, and they took some blood samples to see how much zinc was in that serum. And they reported elevated levels above the normal values. Now, they also took liver and kidney samples from dead animals, and the levels were also elevated. To give you an idea, normal values in liver are between 100 and 400 parts per million on a dry matter basis, and all those livers were higher than the normal range. And in this case, kidney is even better because the normal values, which are between 80 and 125, as we can see here, those levels were more than 10 times higher. So the kidney is probably a better organ to check for zinc toxicosis. Now on the table below they show how much zinc was in the grass silage and the corn silage. If normal values should be between 50 and 100 parts per million of dry matter basis, in this case they had several thousand parts per million, which is way too high and above any tolerable levels. Now, as you can see, the syndrome in cattle is not very specific, but in dogs it appears to be very consistent and goes through different phases. So let's assume he ingested a metal object containing zinc. Once it reaches the stomach, the low pH converts elemental mercury into soluble corrosive salts, and that obviously results in GI irritation and maybe ulcers, so the animal is going to exhibit vomiting, diarrhea, which can be hemorrhagic, lethargy, anorexia, and so on. Now, as the zinc gets absorbed, it will start producing an intravascular hemolysis, and that's going to turn into a hemolytic anemia with hemoglobinuria, bilirubinemia, and jaundice. So at the same time that liver, kidney, and pancreas start to get damaged, there will be isostenuria, proteinuria, azotemia, an increase in the liver enzymes, and these are obviously the worst complications on top of the hemolytic anemia. So if you come across an animal with hemolysis, which is accompanied by finding of a metal object in the gut, zinc intoxication should definitely be at the top of the list. The diagnosis is pretty straightforward if you can interpret the clinical signs and know what to look for. If the animal is alive, you can take blood samples to measure serum zinc. A caveat is that you cannot use red top tubes, only royal blue top tubes, because those rubber stoppers can falsely elevate the zinc values. And there is obviously no substitute for doing radiographs of the abdomen to check for any ingested metal objects. And the treatment is basically symptomatic and supportive. Because of the hemolytic anemia, we may need blood transfusions to restore those packed cell volumes. Some GI protectants such as antiemetics, antidiarrheals, antacid. And obviously any foreign body should be surgically or endoscopically removed from the GI tract. And we could, because zinc is a metal, we could consider chelators like calcium EDTA or penicillamine to enhance the elimination through the urine. But on this case, most papers try to stay away from chelators. They say that it was not necessary and was not provided, because as soon as the source is removed from the animal, he starts making a quick recovery. So really, without removal of the source, the prognosis is going to be poor, and hopefully there is not much organ damage by the time the dog comes into the clinic. Hopefully there won't be much liver, kidney, or even pancreas damage. That would be grounds for a grave prognosis. As I say, chelation is controversial. Both calcium EDTA and penicillamine are also toxic for the kidney, and with zinc toxicosis there will be some kidney damage that could worsen the adverse effect of these chelators. If you remember, calcium EDTA was the ideal chelator for lead intoxications, and penicillamine is the best one for copper intoxications in those dogs that are predisposed to build up toxic levels of copper in the liver. So if you have signs of renal failure with high BUN and creatinine that go along with the lethargy, the anorexia, the vomiting, the polyuria, polydipsia, those chelators should probably be avoided altogether. Now I'm going to try to summarize this paper on 19 cases of zinc intoxication in dogs that was published back in 2007 in JAFMA. The first thing is to say that 17 of those 19 dogs survived after a median hospital stay of just 2 days. So with proper treatment, the prognosis is very favorable. The median days of clinical signs prior to admission was 2.3 days, which, as we just saw, were primarily GI signs of vomiting, lethargy, inappetence, diarrhea, some discolored urine by bilirubin or hemoglobin. This table summarizes some of the results of the blood work. What is typical is a hemolytic anemia. We can see the red blood cell counts going down. In this case, the mean was 1.9, which is much lower than the normal range of 5.8 to 8.9. So the packed cell volume was obviously also lower, and the reticulocytes were high, which is kind of a typical finding for a regenerative hemolytic anemia. And also they noted that there was a stress leukogram with mature neutrophils. Now the biochemical analysis were high activities of some of the liver enzymes like aspartate aminotransferase, alkaline phosphatase, glutamyl transferase, and total bilirubin. It is not included here, but the serum zinc were high in all those dogs in which it was measured. What was a good sign in all those dogs is that the creatinine and BUN were not really elevated. Now the treatment obviously involved removal of the metallic foreign objects by either endoscopy or gastrotomy. 15 dogs received packed red blood cells, 6 received plasma, and 18 received balanced electrolyte solutions. And the other drugs that they also mentioned were some GI protectants, antiemetics, and only 2 dogs received the chelator calcium EDTA. So in the discussion, they mentioned that because the dogs had not really developed any acute renal failure, the prognosis was favorable, and this is why measuring BUN and creatinine is quite important. They also say that the liver enzymes were elevated, but just mildly, and some of those elevations could be due to the hemolytic anemia or the destruction of the red blood cells. So as a final slide, I wanted also to show a lesion, which is what happens in the pancreas with zinc toxicosis. As we have seen, there are a lot of toxicants that affect the kidneys and the liver, but there are not really that many that will target the pancreas. On the left image, we see a normal looking pancreas. The pancreatic juices come from the glandular structures, which are known as acini, and there is a whole network of small tubes known as ducts into which those juices are secreted. Now the section on the right is from a sheep that was given 4 boluses of zinc oxide, and basically there is a total loss of normal architecture with atrophy of those acinar cells. Basically that entire lobule is devoid of those acini, and only the tubules or the ducts remain. And there is also it's not very clear, but there is also replacement by collagen or fibroblast in that interstitial spaces. So this is the final slide, guys. On the next video, we will continue talking about more toxicants that affect the kidneys. So until next one, take care, guys, and bye-bye for now.